Alrighty, this is Algebra 2, Lecture 1111 and 1112. OSA2F11, the student will evaluate functions for given values of the domain. Remember that domains are, when we have an ordered pair, the domain is the first term and the range is the second term. It might be x, y, it might be a, b, it doesn't matter what we label them. But this first term is the domain and the second term is the range. And it could be x. Instead of y, we often write f of x, like that. But we're going to be given elements of the domain. So here we go. Evaluate. Note, this symbol right here reads, that means when we read it and speak it, you say it f of x. It looks like, a lot of kids want to say f times x because it looks like f times x. But when we're talking about, when our context is a function notation, this reads f of x. It's a function of x. And so here we go. We're going to evaluate these functions, and this is really pretty straightforward. We're given f of x is equal to x minus 2, and we want to find f of 9. All that means is we are going to plug in, let me get rid of that. We're going to plug in for our domain value, we're going to plug in a 9 right here and right here. F of 9, so instead of x, we now have a 9, is equal to 9 minus 2. Whoops. And then we can say that f of 9 is equal to 7. And we'll be finished. On today's multiple choice, you'll just look for a 7 among the choices. In some cases, they might write, the instructions might be, write an ordered pair that's a result of this. And if you did that, this is your element of the domain that we're plugging into this function. And whatever we get will be our element of the range, domain range. Okay. This, though, is what we're going to be looking for within the context of the multiple choice worksheet that you're going to be given today. Specifically this, 7 will be the answer. Okay, here's another function, g of a. Remember, this reads f of x. If it's not an f and an x, we still read it. If this was a g and this was an a, this would be g of a. It just tells us that we're definitely dealing with a function. G of a is a squared plus 5a. We want to find g of negative 3. So what we're going to do is we're going to go through this function, and wherever there's an a, we're going to replace it with a negative 3. Whoops. And then perform these operations. Well, this is negative 3 squared, that's positive 9. If you try to do that with a calculator, if you do this with a calculator, if you enter negative 3 and then square it, your calculator will tell you negative 9. It'll follow the order of operations mindlessly. Okay, so if you're going to use a calculator and square a negative number, make sure that you put parentheses around it. And that way you'll get the positive 9. Negative 3 times negative 3 is positive 9, which we all know that. But if you plug in a negative 3 squared like that with your calculator, it will correctly square the 3 first and then multiply by this implied negative 1. Because that minus sign, all minus signs, mean negative 1 times. Okay? So it will perform this operation. Please excuse my dear Aunt Sally, parentheses, exponents, then it will multiply. Okay, so make sure that if you're using a calculator and you're squaring a negative value, put that puppy in parentheses or it'll give you the wrong number. It'll give you the number that you know is not correct. You know that this is 9. So if it gives you negative 9, it means you didn't put it in parentheses. So make sure you do that. If you're using a calculator, you can't just do it in your head. This is 9 minus 15. And 9 minus 15 is, what is that, negative 6? So g of negative 3 is negative 6, and for today's purposes, among the multiple choice answers, this specifically is what you would be looking for. This could be written as an ordered pair, domain, range. Okay. But this is what we'll be looking for today on the multiple choice. It will just be a number. Okay. Take a look at another. G of n is equal to n plus 5. Find g of negative 3. So I have g, instead of n, I've got negative 3. G of negative 3 is equal to negative 3 plus 5. Now, since I'm not multiplying anything by that negative 3 or squaring it, don't need parentheses. You can put them around there, it won't hurt, but I don't need them. Okay. Now just perform these operations. Well, that's 2. Negative 3 plus 5 is 2. So g of negative 3 is 2. And that's our answer. That's what we would look for among our choices today. Remember that this could be written as an ordered pair, negative 3, 2. Today, this is what we're going to be looking for. Let's take a look at another one. So far, we've evaluated all of these functions at numerical values. We valued this one at 9. We evaluated this one at negative 3. We evaluated this function at negative 3. We're going to evaluate this function at a variable value. Okay? And it's simple. You just do the exact same thing. We're going to say f of n is equal to 2n minus 1. Find f of negative 3n. Well, if this was just plain old negative 3, we plug in a negative 3 right here. And then we plug in a negative 3 right here. Since it's negative 3n, we're going to do the exact same thing. We're going to take this negative 3n and plug it in here and here. So here we go. F of negative 3n is equal to 2 times, instead of n, we're plugging in a negative 3n right here. Negative 3n, and notice I put it in parentheses. It's not very neat. I put it in parentheses so it doesn't look like 2 minus 3n. There we go. Minus 1. I plugged in 2 negative 3n minus 1. And then I just evaluate this as best I can. That equal sign looks kind of messed up, doesn't it? So f of negative 3n will equal, this is 2 times negative 3 times n, that's negative 6n, minus 1. These won't combine, so we're done. We would look for this in our multiple choice setting. They would give us several choices, 4 probably, and this would be our correct response. Okay. We plugged in a variable, and we got a variable. And this is the domain, that's the range. If you wrote it as an ordered pair, it'd be negative 3n, comma, negative 6n minus 1. All right, let's take a look at another one. Oh, we have one more. This time we have an absolute value to take into consideration, which you guys all know how to deal with that. So we're going to evaluate g of a is equal to the absolute value of a minus 3 plus 2. We're going to evaluate this function at negative 9. So wherever there's an a, I'm going to plug in a negative 9. So g of, instead of a, I'm plugging in negative 9, is equal to the absolute value of negative 9 minus 3 plus 2. Now I want to stress something here. Whenever you are simplifying an absolute value expression, if it's numerical in here, if there are numbers, make sure that you simplify this first and then take the absolute value. Don't make everything positive and then simplify it. You want to simplify first, then take the absolute value. So I'm going to wind up with g of negative 9 is equal to the absolute value of negative 12 plus 2. And the absolute value of negative 12 is 12. So g of negative 9 is equal to 12 plus 2. And that will give me 14 if I haven't made any arithmetic mistakes. Hopefully that makes sense. With an absolute value situation like that, I said simplify inside first. If we had had something like this, negative 10 plus 3 in absolute value, common mistakes I've seen kids make is they say, oh, that's going to be positive 10. and they'll do this. Because it's absolute value, that's positive. And I can see why they're thinking that, but that's not how it works. And they'll call this, well, that's the absolute value of 13, and that gives us the absolute value of 13 is 13. Unfortunately, as logical as that seems, it's all incorrect. Because what we want to do is simplify this first, then take the absolute value of it. So this would be the absolute value of -7. -10 plus 3 is -7. Now we take the absolute value of it. Okay? So remember that. Simplify first, then take the absolute value. Don't say, hey, negative becomes positive, and then simplify. That you'll get the wrong answer when you do that. Okay? We did it this time because they were both negative, and we add them together anyway. All right, hopefully that makes sense. We're going to evaluate functions for given values of the domain, and when we do that, what we get is a value that is an element of the range, as we remember from Algebra 1. You can do this. Best of luck.